we're good to go? Sweet. Hello, my name is Monty Taylor. I would like to go ahead and start with a few apologies. First, I apologize for not being here this morning, although thank you, Rico, for covering for me. I blame several dudes on various airplanes. It's all their fault. I also would like to apologize to the translators. I'm notoriously terrible to translate. Last year in Tokyo, the translators actually got up and quit and walked out of the room in the middle of the talk. So I won't take offense if you do the same. It's a hard. This is a hard talk, even for people who aren't trying to translate it. So anyway, I apologize for any mental strain that I give on anybody. So we're going to chat about Zuul some. You can get in contact with me on IRC. I'm Mordred. I also have a Twitter handle if that's the thing you're into, and whatnot. As it said on the last slide, a little more about myself, why I'm talking about things to you. I work for a company called Red Hat that you probably have heard of. We do Linux, I guess, or something like that. I am in the office of the CTO there, which means that I get to just run around doing random things that I'm not accountable to anybody for, which makes me very happy. And I get to come and chat with people like y'all. Most primarily, and as I'm sure any of you who know me before now know, I focus all of my energy on OpenStack. I've been around the project since the beginning. Literally set up the original source code repositories. So I've seen it all. I've been there through all of the things for that. Specifically inside of OpenStack, the main thing that I focus on is the OpenStack Infra team, which I've also been on since the beginning. We've had some nice quotes from some people who have interacted with us. I especially like Emily Dunham works on Rust for Mozilla and their CI stuff, and I was at a thing a couple years ago, and she made a comment that we were like the SpaceX of CI, and I was like, that's the coolest thing anyone has ever said to me or will ever say to me. So thank you, Emily, for that. But we work on the project infrastructure. We work on the tools that let the people who work on OpenStack work on OpenStack, right? And we'll be talking quite a bit about that in this talk in more detail. As a part of working on OpenStack Infra, we wrote a piece of software called Zuul, which is what this talk is about. We have a nice new shiny logo, which you can see there in ASCII art form. I also have stickers, if anybody wants stickers. It's the most important part of any journey is pulling stickers out of your thing. So for most of the rest of this, I'm going to talk about Zuul. I'm going to start, hopefully, give you a bit of a sense of why we did Zuul, and then I will talk a bit more about the what. But I want to cover the why first, because oftentimes you're like, hey, we wrote software, and somebody's like, well, that's cool, but why did you bother doing that? And most of the time, it's a bad idea, and you shouldn't ever let me write software, because it's going to turn out bad for somebody. Anyway, also as part of working on Zuul, and this will become clear, I'm pretty involved with the Ansible folks. Zuul itself is Ansible, is very Ansible focused. I also happen to be the sort of maintainer of the OpenStack modules inside of Ansible. So if you use those for anything and they give you problems, I'm sorry. If they're great for you, there's probably somebody else's work, and I just haven't gotten around to messing up whatever they did yet. So cool. I've shown you a bunch of logos, which means it's a good presentation. All good presentations have lots of logos, so we're doing good. My jet lag is not breaking the logos in the presentation. So the quick sort of I ramble a lot, as you probably can already tell. The number of times that I have finished a presentation in the allotted amount of time, I don't know that I've ever remembered finishing on time. So I want to give you the short version up front. of what Zuul does. Zuul is a project gating system. It's focused on dealing, its specialties are dealing with projects that have multiple repositories, but that want to have an integrated deliverable. That's a pretty specific but really hard use case. Its specialty is in gating commits. It can do other things, and we'll talk about what that is. But it really wants to be the tool that helps you gate changes into your source code repositories. Zuul is all open. It's all completely open tooling. And it comes from a couple of different philosophical underpinnings. One of those is that we think that it's really useful for projects if nobody in the project is special. And so Zuul is there to help achieve that. And also have become really big fans of the idea that your testing should be more like your deployment, that you shouldn't have gobs and gobs of testing specific automation. You should have your production deployment should be automated, and you should be using that production automation as part of your testing, because otherwise what are you testing? You're just testing random stuff, and you have no idea whether or not you're validating that the changes are a good idea. So hopefully, after I ramble for longer, we'll have filled in those particular ideas. Although it's possible that I will just talk about scuba diving for the rest of the time, just to make Rico happy. If you really want to waste a large part of your day, find me over beer, and I will start talking to you about scuba diving, and you will not get anything else done for the day. So I mentioned earlier I want to start off by telling you why we're doing this, what the problem is, what problem are we trying to solve, and the problem we're trying to solve is OpenStack. It's our daily problem, our daily challenge. OpenStack has a bunch of features. It's as a project, not as a piece of software. It's a federated project. It's also distributed. It's very large. Everything about it is open, and it also does not exist in a vacuum. What I mean by federated is there are hundreds of involved companies, right? And we like to talk about this on marketing slides, right? Like it's very exciting from a marketing perspective, or some people think it's exciting from a marketing perspective. But it means that we don't have a single main company. There isn't a direction coming from like some product manager in a corner who just decides random things and then everybody has to go do what they say. Everybody, all of those companies are sort of in it together. This brings us, there's a quote from, I think it's from the West Wing, I don't know where it's actually from. They said, decisions are made by those who show up. It doesn't matter who you work for in OpenStack, it matters who shows up, who you're going to talk to, who's going to work on the thing. And that leads us with this idea that we have to solve everybody's use cases, right? We can't just solve one company's use case because that company isn't any more special than a different one. So one set of people wants to do telco use cases, another set of people want to do enterprise workload use cases, and a third set of people want to do, cloud native workloads. Well, all of those are important, and they have to be, because all of those are the use cases that our developers, that our users have brought to us. And it's really easy for people to say on Twitter, you should just stop paying attention to that. Well, okay, but that's not really going to work very well when the people show up and they really want to solve that problem for themselves. That's really great in terms of spreading our ecosystem. It has some downsides. You can't just hire somebody and appoint them to a position in the project. I think there's good and bad to that. Interestingly enough, we can't fire anybody. If somebody is just annoying or they're doing a bad job or whatever, we as the project can't make them go. Their employer might be able to fire them, but we can't. We can't fire anybody. We have to deal with the people who show up, right? We have to deal with whoever the contributors are. Those people have a variable amount of background. We have people who are still in college, who are still young learning. We have people who have been in the industry for 30 years. Those people can show up at any day. They can go away at any day. Contributors come and go, and they have various backgrounds. For all those reasons, we have a very heavy reliance on consensus. One person walks in and says, this is the way it's going to be. okay, are you going to be around tomorrow to still think that? If we don't all agree that what we're going to do is the way forward, then tomorrow when that person decides that they want to work on, serverless instead, people are left holding the ball, which isn't really good. We're also distributed. There is no OpenStack office. Actually, there is the foundation that oversees the OpenStack. They do have an office in Austin, but OpenStack development does not happen out of the office in Austin. Our contributor base is global, as should be evident by the fact that we're standing here in Vietnam and not just in Silicon Valley, which is fantastic. I can't tell you how thrilled I am that is true. That also means we have a multitude of contributor backgrounds, not just from developer skill perspective, but from cultural background perspective. People think about problems in different ways. People interact with each other in different ways. They're all natural and positive, but that are strange when you take a person from the middle of Russia and a person from Vietnam and a person from South America and a person from Silicon Valley, and they've all got different upbringing and backgrounds and whatnot, and we have to accommodate all of that. So we have to have tooling that, and we fail at this constantly, by the way, but our intent is that our tooling empowers all of our contributors, right? That it's not, regardless of where they're from or where they are, this is one of the reasons we have such a heavy preference for text-based communication. And we fail at the third point a lot. I could tell you every time I'm over here visiting, it reminds me how difficult it is to interact with the folks in the US time zones. I haven't solved the problem of the Earth rotating and it being really big yet. I keep working on it, and I haven't quite gotten that one done yet. But we try and design the solutions and the tools with that in mind. It's a never-ending battle. I said it's large. We have a large number of all of the things. We have a large number of contributors. Generally speaking, it's about 2,000 in any given 6-month period of time. We have a large number of changes. We have a large number of code repositories. I apologize, I did not update the number. The last time I checked this a couple weeks ago, it was 1,955. I'm a bad presenter for not having updated that slide, but it's more than 1,955. So it's a lot of source code repositories. I'm not bragging about the scale. I mention the scale because it's our sort of, on the infrastructure team, it's our daily challenge, right? It's hard to deal with that, and it's the reason we've written some of the tools we're going to talk about. As a way of more not bragging about scale, here's some numbers. So we do about 2,000 jobs per hour in our system. We have build nodes that span 13 regions of 5 public and 2 private OpenStack clouds. So we have nodes from all of those. Thank you to all of those providers. This changes from time to time, but generally speaking, we merge about 10,000 changes per month. By way of comparison, and I'm not trying to say, oh, mine is bigger or whatever, our friends at Ansible, who I love deeply, they received 13,000 changes and merged 8,000 of them in the first 4 years of the project's existence. We all know that Ansible is one of the coolest projects out there. That's not trying to, it's just we have this flux of people that we have to deal with. So we have to deal with some things in some tooling ways. I mentioned it's open. Everything about OpenStack is open. I hope everybody knows that. But there's open source, right? We're not open core. We certainly aren't this new commons clause situation that the Redis folks just hoisted on the world. We don't cripple things. We don't hold back enterprise features on purpose. Some of our vendors might. We can't stop them. But as a project, we don't do that. All of our design is open. All of our development is open. Most of you probably know all of these things. Our community is open, right? It's the lazy consensus model. We have public meetings. All of the things we do are in the open. In OpenStack Infraland, all of our operations are open. All of our logging is open. All of our monitoring metrics are open. If you want to go to grafana.openstack.org, you can see the metrics and graphite stats that we've collected from the running systems, from the control plane of the tools that our developers use. I mentioned we're not alone. We have dependencies. There's a ton of stuff that OpenStack is built on. It's not just its own little thing. It's an ecosystem. We're built on top of Libvirt and KVM and Zen and MySQL and Rabbit and Python and JavaScript and all of these things. We have those as dependencies. We have things that sit next to us, Ansibles and Kubernetes and Terraform and all of that. And then we've also got vendors, right? So we're in an ecosystem that we have to exist inside of. So in order to deal with all of that, that's the problem space that we exist inside of in trying to provide tooling to the OpenStack developer community. So our process is very code review centric, and that has been true since commit 1. Nova and Swift existed before OpenStack existed, but from the moment that they were OpenStack projects, they have gone through a code review and a gated commit process. Which is the first thing that we did, and one of the reasons that all of the early Nova and Swift developers loved us so much in the CI team is we took away everybody's commit rights. They were thrilled. Everyone really loved that. But nobody in OpenStack gets to push commits. Everything has to go through code review, no matter. I've been with the project since it was started, and all of my commits have to go up and go through code review. That's how it works. There have been a few times because of disasters where those of us in the infra team have had to elevate position and force merge something, and every single time we've done that, we have also broken something else. So sometimes you can't avoid it, but it's a bad idea. We have a third-party CI system for our vendors, so that vendors who care about their gear can test that proposed OpenStack changes work on their gear. I can't possibly provide a test lab that has all of the stuff in it that all of the different vendors might want to run OpenStack on. It's impossible. I also don't have a test lab, even if I wanted to do that. And I mentioned that most of this is about the gated commits part of this, but it's all about the testing the commits before we land them. This is a nice ASCII art chart of how the process looks. We have humans hacking, clickety, clickety, clickety. They push code up into the Garrett code review system, or maybe they pull it down, and that's a sort of loop for them. And on the other side, we have Zuul sitting over there testing and merging things, and we have humans approving changes in the code review system. So Zuul watches the stream of changes from Garrett and takes actions based on them. If you haven't interacted with the OpenStack in a developer capacity, this is a little bit what your world might look like, especially if you're using Gertie, the text-based interface to Garrett. So this is a screenshot of that. This is a patch that somebody has pushed up. And you'll notice that in addition to some code reviews in there, it turns out that Bob really doesn't like the white space choices that are made by the person who wrote this patch. We've also had a vote from Zuul, who has verified that even though Bob doesn't like the white space, the patch works, and we've indicated that so that the reviewers can do that. And we run, in this case, 2 jobs, docs, and Python 2.7 on this lovely patch to the Hello World project. So the Zuul project is actually a distributed system. I don't think that any of us in the Zuul team would really call it microservices because, well, it existed before that word existed. We just like to call it distributed, which is what the word microservices was before they invented the word microservices. It's a distributed application. It has many services that talk to each other over network connections, just like all good internet applications that have been written in the last 40 years have. It's not going to be a new concept. So we've got a set of things that interact. Several of these are scale out. The Zuul mergers, the Zuul executors, the web and finger gateway are all scale out components. We do have a central scheduler, which we have work on the to-do list to, that's our last final SPOF that we need to get rid of. We have a system called Node Pool, which talks to clouds that gets resources for us. This is also not to scale. I don't really know how big Zuul is physically, but it's probably a different size than that developer. So I've got an architecture diagram, which you have to have in all good presentations. So I mentioned Node Pool. Node Pool is a program, it's a companion program to Zuul. It works very closely with it. It builds new base images daily and uploads them to all of our clouds. Turns out cloud providers like to be helpful, and they like to make value-added features in their base images that they put in the clouds, which makes it very hard to run the same application across 5 different clouds. So we just bypass all that and build our own images. And its job is to create test resources for our test jobs. It creates and destroys at least one VM for every job that we did. So on a normal day, it's creating and destroying about 2,000 plus VMs per hour. Some of those test jobs, as I'll talk about in a minute, are multi-node, so that number can be quite a bit higher in actuality. Also, before I go any further, it's worth pointing out, we've been doing a lot of marketing hype recently about Zuul. It's not new, it's been in production for OpenStack for about 6 years now, so it's actually rather battle tested. Our most recent release, Zuul v3, is notable because it's the first one where we've been focused on people who aren't the OpenStack developer community as users. Other people have been using Zuul for a while. Wikimedia has been using it for I think 3 or 4 years now. But they've never been if you're not the OpenStack developer ecosystem, you've never, up until this release, you've been an afterthought, right? Like it's our job is make sure that OpenStack developers can work, and if you can also use the tool, cool, but for v3, we took that on as a primary. Enough people were using it and having problems because we weren't designing it for them to use it, that we wanted to make sure that it could solve those people's use cases now. So you are all now first-class citizens use case-wise for us. You're all lovely people. It's also now a top-level effort of the OpenStack Foundation, so it's adjacent to the OpenStack project. It's not a sub-project of OpenStack. Although technically there's still an OpenStack board meeting vote that needs to happen to make that fully official, but we did the marketing first to make that board vote awkward. Yay. It's also, I mentioned it's not just for OpenStack, we now have it running in production at BMW that has nothing to do with OpenStack. They're using it for like developing self-driving cars, which is probably the coolest thing that I don't know. It's pretty wild. The folks at EasyStack are running one. The folks at GoDaddy, OpenControl, OpenLab. There's one that's running at Red Hat. I'm sure at this point there are ones running that I don't know about, because we didn't know about the EasyStack one until the OpenStack Summit, which is super cool. That turns out to be how you want that to work. So that's pretty cool. So I've now rambled for probably most of the entire a lot of time, and I haven't really gone into the details. So here's the fun bit. So this is what Zuul does. It listens for code events. It listens for, depending on what your system is, it listens to the event stream for Garrett. It receives webhooks from GitHub if it's talking to GitHub. The big thing that it does is it prepares the appropriate job configuration and the appropriate Git repository states. And we'll talk about that more in detail. It allocates nodes for test jobs using Nodeful, pushes the Git repository states to nodes, and it runs some Ansible playbooks, collects and reports the results, and it may or may not merge change. That's all it does. It's a lot, but like that is it in a nutshell. There's a bunch of people who will ask like, oh, how does Zuul do this? And it's like, Zuul doesn't do that. Your job might do that. You might write some Ansible to do that, but like Zuul doesn't care about, like, is there a Slack plugin for it? No, because it doesn't know anything about those sorts of things. You could write some Ansible to report to Slack, but Zuul doesn't care. That's not its job. Its job is to get the Git repository states in place and run the content you tell it to run on those Git repositories. Everything else is all you. This is all in the service of gating. Right? This is all so that we can do gated commits. What you might ask are gated commits. So this idea that we've talked about of gating is that every change proposed to a repository, you want to make a change somewhere, we're going to validate it. We're going to test it before it merges. Back in the day, people used to be really impressed when you had automated testing that ran nightly, right? You'd push stuff into your dev branch and you had like a thing running on a loop, and occasionally it would turn red, and people were like, oh, you broke the build. That's like 10 years ago stuff. Like that's no good. We want to test it before it merges. We don't want to test it after. Once it's merged, it's merged. It's the wrong time to test it. It's already in. It's already running. So that's great, and that's hard enough. But when you have more than one repository, you get into this scenario that we refer to as co-gating. which is that you want to validate changes to a set of repositories in sort of a monotonically increasing way, such that each change is tested with the current state of all of the other repositories in your system before they merge, right? So you want to make sure that the sum of all of the projects that are going to go into your actual deliverable always work with each other together, right? You don't want to have them be broken for most of your time and then magically your QA team somehow smushes it together at the end and makes a release that works. And then, of course, you get bugs the first 6 months of its release and nothing works, which was the first Austin, Bear, Cactus, and Diablo releases of OpenStack, where we didn't have integration testing. If any of you used those, I'm sorry. They did not work at all. Well, actually, Diablo did, but we had added integration testing for that. That is fantastic, but if you sort of take it to its logical conclusion, the only way to effectively do that sort of co-gating idea is to serialize all of the changes into a single queue of changes so that you can effectively test their proposed states. And if you do that correctly, you can't land very many changes because you're limited by the number of tests that you can run in series. So the thing that the Zuul does is this idea of doing that in parallel. It takes the serialized state and parallelizes it so that you can test more than 24 changes, so you can land more than 24 changes in a day, which is, I don't think our ecosystem would find acceptable if we were landing changes to OpenStack at a rate of 24 a day at best. Of course, if any of those failed, you just lost an hour time slice out of your day, and that's when people start having ideas such as, why don't we run less tests? Or this is too hard. So we want to make sure that we can move fast, but also move strictly correctly. We don't want to give up the validation in order to do that. Also, it's important that all of your presentations have cows in them, so we've got that. So I am successful for the day. If those last words I just said didn't make any sense, we have an animation for you. It's ASCII art, so it's a little bit of strange animation. For the purposes of this, we're going to pick on Nova and Keystone, just two arbitrary projects. The things on the right there are indicating the current tip state of their head of their master branch. And we all know that all you need for OpenStack is Nova and Keystone, so you're going to put those together in an OpenStack cloud, and it's going to be perfect. It's going to be a weird cloud because it's not going to have networking or storage or images or anything like that, but you know, we want to keep this a usable simulation. So what's going to happen is somebody's going to approve a change to Nova. It's a random change. Somebody approves it, so we're going to put it in the queue, and we're going to start running tests on it. Somebody's going to approve a change to Keystone, while the Nova ones are still running. And what we're going to do here is we're going to put that into the queue, and we're going to construct some states to run some tests on it. And they're going to be the state of Keystone master, the state of Nova master, that first Nova change, and the Keystone change. And we're going to build an OpenStack cloud and test that state. Then somebody's going to approve a completely unrelated change to Nova that we're going to put into state. So we're going to have Keystone plus Keystone 2, Nova plus Nova 1 plus Nova 3. They're all going to go into the Git repository state, and we're going to start running tests on them. And somebody's going to approve another change to Nova, because it turns out people approve changes to Nova all the time. And we're going to create some Git repository state there that has Nova master plus Nova 1, 3, and 4, Keystone master plus Keystone 2, right? So we've got 4 different proposed future states of OpenStack to test here. And we're gonna run tests on them in failure. Oh my gosh, the Keystone change, it's failing. It's terrible. There's some things we can know and some things we can't know at this point in time. The first Nova change isn't done testing yet. It's possible that Keystone change failed because the Nova change ahead of it is breaking it, but maybe the Keystone nodes are faster or something, and we just got those results quicker. We can know that Nova change 3 and Nova change 4 have no chance of merging, right? Because they've got a thing ahead of them in the queue. We know that the failure is ahead of them. So what we do here is we cancel those builds. They're useless. They provide no value to anybody. and we take the keystone change and we move it to the side. We still want to report its results, but we can't report its results until we know what the state of the one in front of it was. We then reparent the Nova 3 and 4 changes with that keystone change moved out of the way. We refer to this as the nearest non-failing change that we reparent them on. So now we're going to start testing that Nova 3 change with Nova number 1, but without keystone number 2. And the same thing with Nova number 4, right? And we're going to start running tests on those. The first Nova change is going to succeed. So now, at this point, we know the Nova change, it's good, and we merge it automatically, boom, in the repo. The Keystone 2 change that failed earlier, because there's nothing ahead of it in the queue, we know that its failure state can only be caused by it, so we reject it. Throw it away, sorry Keystone, no changes for you today. We keep running tests, the Nova 3 change passes and we merge it, and the Nova 4 change passes and we merge it. Now all of that sequence of events would be really annoying for a human to do. You'd give up about halfway through and be like, I can't. I'm just gonna merge it anyway. I can't deal with this anymore. But Zuul does all of that automatically and does all the reparenting and remerging for you, which is really handy. There was around the OpenStack Summit, Jess Frizzell tweeted out, what I really want to do is just be able to say, hey, merge this as long as tests pass. And I was like, let me introduce you, my friend Zuul. It's what he does. And sorry, Keystone, we were picking on you. A specific, I mentioned earlier that we have multiple projects, which is what that's all about. Those projects can have dependencies across them. So we have this concept of cross-project dependencies that Zuul can interface. And this is a specific example pulled from me being a bad developer from last year, actually, of a bug that we had in the Shade library, which the Ansible modules were using, that required 4 different patches to get done. First of all, it turned out I had to add a new test job to test the bug. Because I didn't have anything that was testing the tips of OS client config library and Shade together. Then I made a change to the OS client config library that fixed the bug actually. The bug was surfaced in Shade, but the bug fix was in one of its dependent libraries. So we made a change to OS client config to add that same job to it. Then we added a change to actually fix the bug. And then we add another change to Shade to show that the fix worked. So going through this stack, we're able to actually add these new jobs and then validate the change that we proposed without actually landing any of the changes to add the jobs to the system. Because one of the cool things about Zuul is that it actually does all of its configuration for jobs dynamically, and I'm going to talk about that in a second. Moving a little bit quickly because I tend to ramble and I'm going to run out of time. So the Zuul's configuration is all contained in Git repositories because its job is to land changes to Git repositories. This is the sort of base. This is the one piece of config that doesn't come live out of Git repositories, which is the list of Git repositories to look in for configuration changes. So basically, this is what you give Zuul, and everything else is live data. From the system. So in this case, we have a couple different types of repositories. Config repositories are where you put trusted stuff. They have special privileges. And then the project repositories are all of the things you're going to be testing. When you start Zuul up, it reads that config file. And then it goes and asks its fleet of mergers to get the list of branches for all of the repositories in all of the projects that it is in the system. And they all go and they do that because they know how to interact with Git stuff. And then it asks the mergers to look for the Zuul.yaml config files in every branch of every repo in the system. Did I mention earlier that we have 2,000-ish Git repositories? Starting up Zuul cold for OpenStack is not a quick process, but luckily it reconfigures itself on the fly as you go. So it asks it for the Zuul.yaml of every branch of a repo. And then it builds the configuration. When you make a Zuul.yaml change in one of your changes, Zuul is looking at all of these changes as they come through the system. So it looks for changes to those files. It asks that fleet of mergers live for the updated content, and then it actually splices that into the live configuration that is used for testing that change. So if you have a change that contains a change to its testing job, that change will be run as if the testing job landed. So you can have your changes to your test jobs themselves are self-testing. So you don't have the problem of I'm going to change the test job and then watch all of the builds break because the test job itself wasn't tested. And this also works with cross-repo dependencies, as I was sort of showing with the shade and the OS client config thing. So this change depends on change to the job definition, which we often do when we're making changes to the base jobs in the system that all of OpenStack uses. So if they had a bug in them, we would have thousands of developers screaming at us because everything is broken. So you can make a change to it and then just make a random don't merge this change to show that the change to the test job works. So what are these configuration changes that we're making all live and whatnot? How do you do that? So the first construct that you have to have inside of your Zuul configuration are pipelines. If you've used some other CI tools that are out there, you may have heard this word, and you may have, that may give you some notions of what the word pipeline means. It means something different in Zuul land, and I'll also say we got there first. They're the ones who have a weird definition for this word. That's not true. For us, a pipeline it's a change pipeline. So funny. It's usually about where I run out of time. So in Zuul, a pipeline is a definition that connects Git repositories, jobs, and their reporting mechanisms. Right? It's a change pipeline. It's not a deployment pipeline. So it's a pipeline through which changes flow, and we have a different ones. It's a context that you can use to attach jobs to projects. So this is a simplified version of OpenStack's check pipeline, and what this check pipeline does is it runs independently, so it doesn't do the crazy animation thing that I showed you. It just tests the changes as you push them up. We use this to test patches when you submit them. We run tests on all of our patches twice, actually, it turns out. We want to run them when you uploaded it, so that we're not wasting reviewers' time reviewing broken patches. If it doesn't pass the tests at all, it is not worth anybody's time to review it. It's a waste of time. You need to get at least passing tests. Then we can talk about whether it's a good idea or not, right? So that's what this pipeline does. This says when a patch set is created in Garrett, or when a change is restored after having been abandoned, we want to run jobs in this pipeline on that. And we want to report back verified one if they're successful. The gate pipeline has the dependent pipeline manager, which does the crazy animation I was showing. From Garrett, when somebody adds a comment, that is workflow +1, which is just an arbitrary column we added to our Garrett. It's not a real thing, it's just an arbitrary thing, so it's just in the config here. That's when we want to trigger jobs in this pipeline. And when they're successful, we want to vote verified +2, and we want to submit, which is Garrett speak for merge the patch. So what this is saying is when jobs pass in this pipeline, merge the change. Jobs themselves are run on nodes from node pool. They can be static or dynamic. You can have predefined nodes. They can be any kind of machine you want. You can define metadata about those jobs in Zuul's config. You define what content to run in Ansible. We originally wrote a tool called Jenkins Job Builder, which we use to express jobs, and it looks remarkably like Ansible playbooks. Because ultimately what you're doing is run this shell script on this node. We didn't really want to write our own language for that, so we picked Ansible. Jobs can be defined centrally or in the repo they're being tested in. We have both in OpenStack land. And they can have contextual variants, which is kind of cool. So this is a base job. This is the base job, or it's a base job. All jobs in Zuul, if they don't list a parent, their parent is the base job. All Zuul really need a base job. And this is where you put system deployer specifics. Where do you want to publish logs, for instance, right? How do you push the Git repositories onto the nodes? things that most people writing jobs for their tests don't need to know about. So in our case, we push some things on, we run some things at the end of it, and if you don't define anything else, this is going to use the CentOS 7 node as the build node. An example job using that, this is a thing a deployer needs to write. Most people don't need to touch this. A simple job using that, here's an example of one that runs talks, and it has a setup in the pre-run playbook, it has a run playbook, and it has a post-run playbook. As you may have picked up already from context, there is inheritance in Zuul jobs. So in this case, you can say this job talks pi36 is a job that has the talks job as its parent, and it's just going to set this variable, talks end list pi36. So it's going to run the talks job, but in this context. Inheritance works like an onion. So we're going to run the pre-playbooks in order of inheritance. We're going to run the run playbook of the job. There can only ever be one. You don't inherit run playbooks. They override. And then we're going to run post playbooks in opposite order. So we're going to build up, run, tear down. If pre-run playbooks are intended to be setup things. They shouldn't fail. These are like get state ready for the testing. If something fails, it's usually a transient network, something happened in the world. We're going to retry jobs automatically if they fail in their pre-playbooks. If post-playbooks fail, we're going to keep running all of them because those are teardowns. You don't want to stop shutting things down just because one of your stops. Yes, and I'm out of time. So just to finish up that thought, this is an example with those jobs that have been built up of exactly what that means. I probably should have said this at the top. These slides are all online. They're in my Git repository, so if you go to git.inaugust.com, you can grab the source code for my website, inaugust.com, and all of the stuff are in there. There's a bunch more of these, so I'm more than happy to chat with anybody. If you'd like to, and you can see I don't usually get through the end of talks, so I will pop at the end. Find me around and we can chat further. Here are links of things. Zuulci.org is our brand new website. You can get the source code at git.zuulci.org. There's docs for things and whatnot. And we are on Freenode in #Zuul. And I will be in Hanoi for at least a couple more hours. Probably more than that. But anyway, thank you all for listening to me babble, and have a great rest of the thing.
And actually, we can ask him some questions.
Oh gosh.
Next session will be
terrifying.
Tea break.
Excellent.
Regarding the Ansible playbook, first, let me introduce myself first. I'm a network engineer, and we are building something to make change to the networking device, or maybe into router on the open virtual, for example.
Yes.
So before I change my code, I want to set up the networking device, or I want to set up some environment on OpenVirtual.
Yep.
That means I want to pass some variable from you to the Ansible playbook. Is that supported? Because on Ansible I don't see it.
Yes. Yeah. So there's two answers to that actually. So cool. Yeah. One of the things we like about Ansible is that you can do crazy things with networking devices. From Ansible, and the Ansible network folks are actually using Zuul to test Ansible network and spinning up network switches and doing stuff with them, which is really cool. But your actual question, yeah, you can define in, see if I can scan for an easy answer. Probably not. I can answer your question without looking for anything big.
No, I mean,
Yeah.
maybe in my change, in my commit,
Yeah.
I mark something like this chain will affect router number 1, router number 2, router number 3, and I want you to pass that chain on to Ansible, so that Ansible know which nodes should be tested again.
Yeah. So there's ways to structure and do the thing you're. I think there's, if I'm understanding correctly, the job itself can certainly run on sort of variable targets, and you can configure the jobs to say, okay, well I did this, I want it to test in these environments, Yeah, absolutely.
Thank you.
Okay, thank you for your presentations. I have a question that can you compare between the Zuul with Jenkins, and why did you decide to do Jenkins from CIC?
Yeah, that's a great question. I don't spend a lot of time in presentations talking about Jenkins because I don't want people to get the wrong idea. So first, I want to say we used Jenkins behind the earlier versions of Zuul for several years, and so we're very thankful to that project. So it's a great project. We initially wrote Zuul to encompass this idea of gating, or to understand, to have a system. Our initial things were done in Jenkins, and the problem is that Jenkins didn't know what we were trying to accomplish with the Git commits, and so it all got very weird, right? It got very complicated. And so sort of writing the thing as an external driver to Jenkins was where we went. As we scaled out, Jenkins was never designed to be a scalable large web service. It was designed to be a tool, right, for people to use. We're running a large internet facing service. So we had to do lots of things to scale out Jenkins's for our needs. And in order to do that, we had to rip out the use of most of the Jenkins plugins, most of the fancy stuff that Jenkins does. And so the value add that Jenkins provided to us was very little, and we were essentially using Jenkins only as a remote shell execution environment. And running a large Java service to be able to run shell scripts on remote nodes is not really a great architecture. It's just overkill, right? It wasn't providing the things that we needed, because its focus on how it's serving its users is just oriented differently. So we replaced it with Ansible, because Ansible is a nice small thing that does its job of run tasks and promotes nodes really well. The other reason is that Ansible is by its nature structured to do multi-node things. You can describe, here's my inventory of 5 nodes, I want to run these tasks on these nodes and these other tasks on the other nodes. And that was really important as we're talking about testing OpenStack, right? Just testing on one node, it tests some things, but it doesn't test everything you want it to test. And so getting that native multi-node structure was one of the other things that was really important to us to be able to do. And the third one is that, and I apologize I didn't get to this piece in the talk, is we like this idea of using your production, using a thing that's like production in testing rather than using a testing tool in production. So like there's a lot of people out there who will take their Jenkins CI server and promote it really and have it be running their production automation. And that to me seems like the wrong direction, right? Like I want to write my automation for production and then use that production automation in a testing environment, right? Like, and so that's just a philosophical thing. There's no reason you can't use it on the other side, but yeah, that's there's a few reasons. Anybody else?
Okay, I have a question about Ansible. So we all know that Ansible delivery is very, very fast. So how do you handle the changes to the release of Ansible to reduce the breaking chance of Ansible?
Yeah. Right now, Zuul is expressing a dependency on Ansible 2.5. At least that's what we're running for OpenStack. 2.6 is already out. We're looking into possibilities of having there be multiple available Ansible versions that are selectable on a per job basis. So you can say, this job wants to use 2.5, this job wants to use 2.6, and have those be available. Nobody's done the engineering work on that yet, but keeping up with that is kind of really, really important in order to be able to, even once you get, tens of thousands of job definitions that are all out there and all defined across thousands of Git repositories, validating that upgrading the Ansible that Zuul uses isn't going to break them is hard. So we're we're conservative at the OpenStack side on doing those upgrades. Also, it should be noted that we're working with the Ansible team to start doing Zuul tests on Ansible itself. So we want to be able to provide feedback to them. Hey, if you make that change in Ansible Devel, you're going to break us down the line. So we're sort of also trying to get that feedback loop so that they can iterate quickly like they want to. They don't want to break anybody. And so the more feedback we can provide them is better. But I think ultimately we're going to have a menu of Ansible versions for jobs. It's inevitable. It will happen sometime. You just have to write the code. It's just code. It'll be simple. Yeah.
What's a good way to try out?
I know that Paul Belanger has a set of Ansible playbooks called Windmill that'll stand up a Zuul. BMW and GoDaddy are both running their Zuuls inside of Kubernetes. BMW's is running in OpenShift, and GoDaddy's is running in normal Kubernetes. And we haven't quite gotten to the point where we've been publishing Helm charts or anything like that, but that's on the horizon. We're also about to start publishing Docker images to Docker Hub of the things. So there's a and there's also folks at Red Hat have a thing called Software Factory, which is it contains more than Zuul, but it's a sort of, it's not really a product because there's not a product selling motion around it, but there's a project that's like an installer for Zuul and other tools that you can get that. So I would say some, depending on what your operating environment is, those are great ones. Another one is it's important to point out that there's a big difference. A thing that I didn't have to. So Zuul is also a multi-tenant system. It's designed because of our scalability in OpenStack land. A lot of the way that organizations scale out with tools like Jenkins, which you mentioned earlier, is there's usually lots of small Jenkinses, right? Like a company might have 100 Jenkins installations. The intent is not that a company would have 100 Zuul installations. The intent is there would be one, and that there would be lots of tenants inside of that Zuul. So depending on what you want to do, finding the existing running Zuuls and just playing with jobs inside of it, getting a tenant. The Software Factory folks are always happy to give new people tenants of theirs. We're hopefully getting to the point where we'll be able to do that in OpenStack land as well. If you do want to run one, that was the first question I answered. But if all you're looking for is to use it, you may actually just want to use one that's somebody's running as a service as well. Both of those are options and should be fully viable options for people, depending on your goals.
Thank you. So any plan to make Zuul to become a CD, not only a CI? So I want to ask
Yes. We actually, that's actually accounted for in the original Zuul v3 spec, and we're reworking some of Infra's control plane, how we're doing config management for that and everything, and as a part of that, we're shifting more heavily to Ansible, and so we're planning on eating our own dog food in terms of using our Zuul to deploy itself. So that'll be happening in our production environment in the next month or two, probably. So yeah. So that's definitely, there's a couple of features missing. They're written up in the spec, we haven't implemented them yet. For actually doing that safely. But once those are done, we're working towards that for sure.
Thank you. So we finished the session right now, and please go out and take a tea break for around 10 or 15 minutes. Thank you.